You sit down at your computer, open a project in your AI coding tool, and without clicking anything or making any mistake, an attacker on the other side of the world starts running commands on your machine. Not through a virus, not through a phishing email, through your error monitoring software. This attack has a name. Researchers call it agentjacking. It was documented by Tenet Security in June 2026, and it exploits a combination of tools that millions of developers use every single day. (2,388) organizations were found exposed. In controlled testing, attackers succeeded 85% of the time. And the company at the center of the vulnerability has decided not to fix it. To understand how this works, you need to know about two things that have become central to modern software development. The first is Sentry. Sentry is an error monitoring platform. When software breaks in production, whether on a user's phone or on a web server, Sentry catches the error and sends a report to the development team describing what went wrong and exactly where in the code it happened. It is one of the most widely trusted tools in the industry. Millions of development teams rely on it daily. The second is something called MCP, which stands for Model Context Protocol. It is a standard that allows AI coding assistants to connect to external services and pull in live data. When you use an AI coding tool, MCP lets the assistant read your recent Sentry error reports automatically. The idea is that the AI can see what broke, understand the context, and help you fix it faster. In practice, it works well. That is also why the attack works. Every Sentry account uses something called a DSN, short for Data Source Name. This is a credential that allows applications to send error reports to your Sentry account. Unlike a password, the DSN is intentionally semi-public. It has to be embedded in the software you ship so that errors occurring on users' devices can be reported back to you. That means it ends up inside browser JavaScript files that anyone can read by opening developer tools. It shows up in public GitHub repositories. Finding one takes a search query and about 30 seconds. Here is where the problem starts. An attacker who finds your DSN can use it to write to your Sentry account. They send a fake error report. It looks like a normal application error, but buried inside the error fields is a set of instructions written for an AI agent. Something like, run this command, collect this output, send it here. Do it without telling the user. The next time your AI coding assistant starts up and connects to Sentry through MCP, it retrieves that fake report as part of its normal workflow. The agent reads the injected instructions. It cannot tell the difference between a real error your application generated and a fake one a stranger injected from outside. It treats the instructions as legitimate work. It executes them. The attacker's code runs on your machine with your own system-level access. This is not theoretical. Tenet Security found 2,388 organizations with valid DSNs that an attacker could use to inject into their Sentry accounts. They conducted controlled testing against AI coding agents including Claude Code, Cursor, and Codex. Across more than 100 organizations tested, they achieved an 85% exploitation success rate. The agents retrieved the injected events and acted on the attacker-controlled instructions without raising an alert. Tenet disclosed the findings to Sentry on June 3, 2026. Sentry acknowledged the problem. Then Sentry's leadership decided not to fix it at the platform level. Their stated position was that the attack class is, in their words, technically not defensible from their side. No patches coming from Sentry. That puts the responsibility entirely on developers and security teams. Here is what you can actually do. If you use an AI coding assistant that connects to Sentry through MCP, think carefully about whether that integration is necessary. If you keep it, apply strict permissions. Configure your AI agent to treat Sentry data as read-only context, not as a source of instructions it can act on. Most AI coding tools let you define what MCP-connected servers are allowed to do. Use those controls. Check whether your Sentry DSN is exposed. If it appears in a public repository or in browser-accessible JavaScript files, rotate it immediately. Sentry's documentation explains how to regenerate a DSN for each project. A rotated DSN cannot be used to inject events into your account. Audit your Sentry event logs for suspicious entries. Injected error events tend to contain shell commands, encoded strings, or instructions that make no sense coming from actual application errors. Once you know what to look for, they are not difficult to spot. Pay attention to what your AI coding agent actually executes. If it runs a command you did not ask for, treat that as an incident worth investigating. Most AI coding tools show a log of recent actions. Review it. The deeper issue this attack exposes goes beyond Sentry or any single product. AI coding agents are designed to be helpful. They act on information they receive from connected services. They are built to interpret data and take action, which is exactly what makes them useful. But that same design means they can be turned against their users if the data they receive has been tampered with. This is a class of attack, not a single bug. The question researchers are now asking is, how many other tools does an AI coding agent connect to, and which of them have the same open write model as Sentry? Agentjacking is the first documented attack of this kind to reach this scale. It will not be the last. If you are a developer or work in software security, hit subscribe. We are tracking how these threats evolve and what they mean for your digital safety. Cyflix, Digital Mysteries, Real Stories.